recording. So, I wanted to take a minute to talk about the steady rest that I built. Unfortunately, I lost quite a bit of video footage. So, I wanted to review this and just let y'all know how the project went. So, in the last video, I stated that this had been plasma cut. It's roughly a 6-inch inside diameter and a 10-inch outside diameter. Counterboard for the button head screws. The bottom plate has been machined for the way. It is not surface ground. My surface grinder is not currently working at the moment. I made on the video I made the pinch bolts for the material. This is 3/4 10 with 3/4 10 nuts, machined down to have a 1/2 inch grab on the back end of it. I can use a 1/2 inch wrench on the side. So you're not going to be applying a whole lot of pressure, but you want it locked into place real tight. So that all worked out real good. The wear pads on the end are actually a nylon type plastic. They are machined so that they are captive, but they also rotate so that when I tighten it up, they grab the material and I can tighten them up pretty good, keep them tight, and it's done fairly well. There's no wear on the end of the plastic. On the opposite side, the bolts were too long for the button heads, so they were just cut off to length to give clearance to make sure that they weren't going to run into the chuck or anything like that. But it does fairly well. These are 2x 2x1 blocks that are machined for the 3/4 10 bolts, the pinch bolts. Welded some nuts on, and then I used the outside lock nut as a lock. It works really well. Does the job that it needs to be done. Can't say too much about that, but I did want to get y'all a good look at it. The other thing is the nut that actually sits on the bottom underneath the ways. I machined it at a radius on the end. Took my divider, went from center point to here, and gave it the radius that I needed, so that when I put this on the lathe, it automatically locks in place, and I don't have to try and get a wrench on the bottom side of it to tighten it up. It does have to be tightened up, and I didn't want it to warp, so yeah, it's made out of 1-inch steel. Works quite well. I'll give you another look at it sitting on the lathe. So this is a mock-up. It's not like a real job or anything, but I just wanted y'all to see that it doesn't take a lot of pressure. I locked it in. It just stays pretty still. I can't account for the bend in the pipe. It's just a piece of pipe. But I want you to see that, yeah, it runs. It'll do the job that you planned on doing. Alright, so this is a shop-made tool. It's boring bar. I've seen another one made that was quite a bit larger, but I have no reason for something quite that large. It's got a 3/8 cutting bit in here. I think it's actually like 12mm metric. Wasn't too worried about that. I just used a piece of 2-inch pin, Relieved it down to, I think it's 5/8, maybe 3/4. Try zeroing it first. Yeah, we're about 3/4, so it fits in the CXA tool post holder. I don't often cut a large hole, but when I do, I like it straight, and the flex in the boring bar kind of does a lot to inhibit that. So this was made so that I wouldn't have the flex. I don't run deep cuts. I'll run another boring bar and bore out the hole, and then put this one in and make sure that the wall and the interior wall in the hole is nice and straight, because it's really good at that. But it has to have at least like a 2.5 inch. I think it's a 2.5 inch hole. Yeah, about a 2.5 inch. It's like the minimum that this will do. And I have been asked to make 3-inch holes in a piece of tube. We use them every now and again for bosses, bushings, that kind of stuff. It works quite well. Shop made tool, 100%. And all I had was a piece of stock steel. I think it's 4140. Not really sure. Kind of a lot of what I get around here is mystery steel, so we have to just use what we get. We have a couple of fly cutters that I made. Can you spot the one that Bozo helped me with? One's right, one's left. So I don't exactly know what I was thinking, but these have to be straight shank for the mill. It'll handle a 3/4, so this was 750 thousandths out of a 2-inch round stock. My cutting edge is over here, my center line is over here, so it works real good. It's a fly cutter, but it was made incorrectly. It really irritated the crap out of me, so I made a mate. Same thing, 750 thousandths on the shaft, 2-inch bore, 2-inch rod. They're drilled out for 1/4 inch, 1/4 set screws to hold them in. Matching pair. I have found out that the surface finish with the sharp teeth as opposed to the round teeth, the round gives me a lot better finish. I'm still using the sharp one. I'll cut the surface down, make it nice and flat, and then I'll swap my fly cutter over to this one and then run it, and it gives me a really nice surface finish with the round cut. So works out really well. I wanted to thank Pragmatic Lee for the idea of using the round high-speed steel. Gives a really good surface finish. My surface plate. My surface plate is a chunk of steel and homemade height gauge. So it is flat. It's not machinist flat by any means necessary. It was a piece of steel that was laying around. I checked it with a straight edge and I didn't find any warp in the plate, so I cleaned it up and ran a bench stone over it, and it gives me a flat surface that I can check the height of my parts. The height gauge is, I believe, a ground piece of steel. That was given to me as is, aside from the set screw holes and the slot. I cut that with the mill and a slotting saw, just deep enough to handle a cheap combination square. Use the combination square. I take my block, make sure that this is level. Check that. Zero that. Check this. And I'm sitting at 0. And that tells me that I'm straight. Not machinist straight, just straight enough. For the jobs that I do, they're not high tolerance. I'm very often asked to mill or bore a hole to extra diameter for clearance because we don't want pins and bushings seizing. And I work in the refuse industry, so a lot of dirt, a lot of trash, you get a lot of junk in there, and the pins tend to seize up. Lubrication goes a long way, but there's a lot of parts that are inside of a refuse truck that do not get lubricated on a regular basis, so they tend to seize up. In order to account for that, we bore for clearance and machine flats just a little extra, just to give it the slop that it needs to run. This is not a high precision job by any means. I'm very often asked to make a pin and they're standing by waiting for the part. So it's hurry up and get it done. I don't care if it's over tolerance by 10 thousandths, 50 thousandths, it doesn't matter. If the pin goes in and the machine runs, then the job's well done. But this is my homemade surface gauge that I use to check the parts. When I check right now, actually, it's set up to check a part, so I don't really want to change it. The tolerance that I'm looking at 3.750 from surface plate to here, and the parts that I'm currently working on, it just barely touches the top. I'm riding on the surface plate, it's nice and smooth. Since I run a bench stone over it, it's getting a little bit shinier and a little bit shinier day by day. So, but it's a regularly used tool for what it's needed for. It does the job very well. I wanted to take a minute to show y'all a newly acquired piece of equipment. This is a 36-inch stomp shear. It's made by Niagara. There's our model number, 136F. It's it'll do 12 gauge from what I understand. I haven't tried it yet. I know that it won't cut 1/8 inch steel 10 gauge. So it's going to be one of those machines I got to go through. It's been sitting outside. Needs a lot of work. Really considering moving the pivot point. Get around here. I was thinking about moving this pivot point because this determines our shear force. This pivot point here, moving it halfway in between the shaft, and theoretically it'll double the shear force, but not sure quite how that'll work. Gonna try it and pray that we don't break anything. For the business sake, it really needs to cut 1/8 inch or it's useless to me. The machine's capable of doing it, except that it doesn't have the leverage that it needs. So in order to change that, we're going to give it more leverage. And we'll see how that works. The rest of it needs to be cleaned up. I'm really considering going through this piece of equipment and shining everything up, give it a new coat of paint, maybe a new life, hopefully. There's a few repairs that need to be made. This one's bent. I don't know if you can see that, but it's not been abused, but it's been left out in the weather, and it really needs to be gone through and cleaned up. Let's see what we can do with that. This is another acquisition piece. It's a 4-foot finger brake. On the label it says that it'll bend 22 gauge. It's for body parts and such. It's also been left out in the weather. Everything works. Not a whole lot of leverage there. It also needs to be gone through, greased, cleaned, repainted maybe. We'll see how that goes. A whole lot of projects, nowhere near enough time. You know how that goes. Love that label though, that flag. Decent piece of equipment, acquired it at a good price, so I didn't complain. But there it is. I wanted to show you all this. I did a new to me video on it a while back. This is a KO Lee 6x12 surface grinder, and it was an acquisition made a couple months ago. Unfortunately, it's been modified. The problem that I have is that my depth of cut is only 2 inches wide. It is sitting all the way in right now, and that's as far as the stone will reach. Now, when I got this, it did not have an arbor on it, so this arbor had to be made to fit a stone. It's not balanced. It runs well. The machine runs well. It's direct drive. It does not have a belt. Some of these are made with belt drives. The motor will be mounted up higher and the spindle down lower, and there's a set of belts inside this column. However, this one does not. It's direct drive, so it has a lot of height, but it has no reach on the stone. So what inhibits that is this box here. This box holds the screw drive for the lateral movement in the table. Lateral movement is supposed to be handled by this motor here. Now, I believe this is a servo motor. Somebody told me that they thought it was a stepper motor. It works. You can see it's all electronic. The control panel here handles the right and left movement, run and jog. When turned to the run position, the table will send itself to home and stop. It does not return. It also runs very slow. So my thinking is that this cable here is supposed to be for a speed control and limit switch. However, that part was not given to me when I bought the machine. Now, when I bought this machine, I got it, it was an eBay for $177. I don't think I really lost out because it is a running machine. However, I'm gonna have to dump a few bucks into it to make it right. I have contacted LeBlond, who is they've taken over KO Lee a few decades back, but they took over KO Lee, and they now make KO Lee parts. However, this is like a 1980s machine, so finding the correct parts may be a challenge. I'm not quite sure. I'm going to need the wheel and the lead screw for the shaft from there to the rack gear that goes inside. The rack gear is supposed to be mounted to the bottom of the table. However, it's missing. The gear that meshes with the rack gear is missing. The whole drivetrain is missing. The table, there's nothing to hold it down. See if I can. The whole table moves. It's not set correctly. So this is going to have to be removed with the motor and then replaced with the rack gear. I may even send it in to have it have the ways scraped. I'm not sure. The cover for the grinder, the box, was homemade. Let's see. This is the cover that I was given with the piece of equipment, and maybe you can see that. This was mounted to the top of the spindle. It was mounted to the top of the spindle here to cover. However, it will only handle like a 3-inch stone on the grinder. So the company that owned this previous to the man that I bought it from probably had it for a very specific purpose. They made one part, they made tons of that part, and that's the only thing that this machine was for. It does work, but running is an absolute pain in the butt because it's just really slow, and it does not give a good finish because when you step over too far. So this is on the docket to be repaired. Gonna take a while though, so as I make progress, I'll try and keep a video log, see how that goes. All right.
Merry Christmas!